extremely happy to have David Card at Connection Universidad today. He's going to give a regular seminar. The only thing is that the room is larger and there are many of you here, but the typical rules will apply. So questions, interruptions, comments, everything that you want. So let me very briefly introduce David Card that you all know. He's a professor at the University of California, Berkeley. He's also the director of the Center of Labor Economics and the Laboratory for Econometrics. And as you all know, he won the Nobel Prize in 2021. I want to quote exactly, because I have a comment for this, for his empirical contributions to labor economics. This is very surprising because these are very general statement. And indeed, this is because David has worked in all important topics that you can imagine in the field and many, many contributions, so very deep and very wide. So he's worked on immigration, on the minimum wage, on intergenerational mobility, on unions, on wages, health, social programs, you name it, okay? And in doing so, he has inspired generations and generations of students. Many of us are here today. We're not students anymore. So in this sense, we thought that today was very appropriate to have some of our students here. So we wanted some of our undergrad students to be here to experience what is it to be in a research seminar. So you're very lucky because probably it's your first seminar, and this is an amazing seminar that you're going to see. And I really hope that you will also get inspired by David in the way that many of us have been. So David, thank you so much for having us and all the patience for the technical problems, but let's get started. And despite the setting, this is a regular seminar. We can have questions and we'll go along. Thank you very much.
Thanks, Maya. How long am I going for?
So we go for 75 minutes.
Okay. So tell me when there's 15 left. Just go like something. Okay. Okay. Well, thanks very much, everyone, for coming, especially students. I didn't realize that there was going to be a more diverse audience. So I proposed to present a seminar on a topic that I've been working on for the last year or so with my two colleagues, Jesse Rothstein and Moises. And Moises is at the Census Bureau. And because of that, we're able to use a very unusual data set that I'll be talking about to study intergenerational mobility and earnings. And let me get right into it. So sometimes when you see a seminar like this, there'll be like a 20 minutes introduction, which is usually a total waste of time. So I'm not going to introduce, I'm not going to tell you what I'm going to do. I'm just going to do it. Okay. So don't get confused. So intergenerational mobility is a topic that's been studied by economists for many decades, and it originates from Galton, the person who invented the term regression. So if you take an econometrics class, you know what regression is. And Galton used the term for regression to the mean. He was thinking of a situation where the children of highly accomplished parents do worse than their parents, and the children of less accomplished parents do better than their parents. So you tend to regress toward the mean. And it turns out that's actually true. Generically, not just about earnings or income, but it's true about height. So I don't know if you know this, but your height is about 40% combination of your mother and your father's height, and 60% your generation. And that's true across people. It's true of lots of other aspects of things that are behavioral as well as seem to be more genetically determined. And so the standard setting for in economics and sociology to study intergenerational mobility of income or earnings is to run a regression of child earnings. So that's this variable, the Y variable on the left-hand side. And that's going to represent earnings that the children are experiencing, but in their 30s. So somewhat older than most of the people in the room, but less than half of my age. and on the right-hand side, we're going to have a variable which represents the earnings of their highest earning parent on average during the time that the kid was early teenager. Okay, so, and it turns out that this kind of model has been used pretty extensively. Um, Most recently in the US, you may have seen this name. This is Raj Chetty. And Raj is a professor at Harvard, but he was my colleague at Berkeley some years ago. And he and a bunch of colleagues have written a large number of papers looking at intergenerational mobility in the US context. Sometimes, probably the thing that most people are aware of is showing that this coefficients beta 0 and beta 1 are different in different communities in the United States or different states in the United States. And I'll be using this term fairly extensively, CZ. CZ is a commute zone. Z is the way that Americans say Z, in case you're wondering. I grew up saying Z, but you say Z. So CZ means commute zone, and that's like a area where people have kind of a similar labor market defined by commuting patterns. And in the work of Chetty and his co-authors, they distinguish between how differences in communities are associated with differences in the intercept of that regression, beta 0, and differences in the slope. And they call differences in the slope differences in relative mobility, because that's how much different your outcome is depending on where your parents' income was, conditional on which community or which place you lived in. And the differences in beta 0, they call absolute mobility. And we're going to be focusing on both components, but we're going to extend this framework a little bit to a two-dimensional model where we relate the earnings of children to the earnings of their family or their parent, and the second term there, y bar above, that's what economists usually use to denote the average, and n of I is the neighborhood where this kid grew up. Okay, so what we're going to do is we're going to relate your earnings as a young adult in your 30s. Well, that's not that young, but young for me. To the earnings that your parents had when you were a kid, and the earnings of all the other parents in the neighborhood that you lived in when you were a kid. Okay? And we're going to try and distinguish the role of those two variables. Now, why is that useful? Well, if you think about it, if you think of somebody who grows up in a specific neighborhood, they part of their earnings that they take that is independent of their own parent is the component, a combination of delta 0 plus delta 2 times the average of the other families in the neighborhood. And so this is a simple model for what determines absolute mobility in the Chetty term. So if you grow up, if delta 2 is positive, and you grow up around lots of other high income families, then you're going to have higher income later on in life. And what we're going to show in the paper is that delta 1 and delta 2 are surprisingly similar in size. So that's going to be kind of a takeaway from these results. Okay, so here are some of the questions we're going to ask with this simple working model. As I mentioned, how big is delta 2 relative to delta 1? This is very controversial in the United States. A couple weeks ago, this very famous but extremely well known for being grumpy economist James Heckman wrote a letter to the Wall Street Journal saying that neighborhoods don't matter at all. And that all this research showing that neighborhoods matter is completely gibberish or garbage or crap, all those kind of nice words. I'm going to argue that that's not true, but so it's very controversial. And the reason why, of course, is because you can choose the neighborhood you grew up in. You really can't, choose your parents, but your parents can choose where to live, and that could be confounding a causal interpretation of this delta 2. We'll ask what happens if we try and, instead of including the mean income of the parent, we include just a dummy variable representing all the things that are different in that neighborhood. And that's a common technique in economics to do that. And ask how much of the variation that you see associated with neighborhoods is captured by this y bar n. Related to that, we'll say the earnings of parents in the neighborhood, a good summary of the neighborhood characteristics, or there's something else that does better. Then we'll use this framework to compare black and white children. As you know, in the United States, a major social issue for many, many generations has been the fact that black individuals earn less than white individuals. And some of that is going to turn out to be related to the two components of this model. Quite a bit of it is going to be related to the two components of this model. And then finally, we're going to look at the role of firms in firms are going to play a particular set of roles, building on a whole body of research over the last 20 years in labor economics, which decomposes earnings of individuals into a part that they take no matter what job they work at, and a part that's specific to the firm that they work at that point in time. And that part that you earn just because you work at a given firm, we're going to call the firm wage premium. And I like to give the example in my area of two universities that you may have heard of. One is Stanford, which is just down the road, and one is Berkeley. And a lot of people actually have moved between those two. But if you work at Stanford, you earn about 20% more than if you work at Berkeley. And that isn't just true for the professors. That's true for the secretaries. That's true for the janitors. That's true for the people that are the administrators. So wages in Stanford are just quite a bit higher than the wages at Berkeley. Stanford is elite private university. It's the hardest university to get into in the United States. Berkeley is a public university, kind of a poor neighbor. So there's basically a 20% wage premium for working at Stanford, and we're trying to think about how do those kind of wage premiums can you inherit those from your parents? Can you get those from neighborhood families? And does that transmit into your own firm premium, or does it transmit into the part of the earnings that you get no matter where you work, or does it transmit into both? Okay, so let's just to briefly summarize. There's quite a bit of work on intergenerational mobility, and a lot of it is summarized with maps of this kind. I'm not going to show any maps today. The reason why is because the data that we're using is confidential, and we're not allowed to construct maps. So, but also, I never find it very useful to look at maps. I mean, maps are kind of cool. You know, Spain looks like this big thing, and there's Madrid in the middle, and Barcelona over here, and then there's a lot of low-wage places, right? So that's what you're going to learn if you see a map of Spain. This is more the style of thing that we're going to do. This is a sort of a way to think about what's been established so far in the black-white literature. So in this research by Raj Chetty and his team, they put on the x-axis, they put the household income percentile that you grew up in, and they use the national percentile. So you would say like your parents are in the 70th percentile of the national distribution for their generation. So they'd be over about here someplace. And I'm assuming if you're a Kunif, maybe it's a little higher than that. And then there's other families that are all the way down into the bottom. So and you remember about percentiles, there's an even distribution of families across that. Okay, like 1% are the 1%, and 10% are in the bottom 10%. That's the cool thing about percentiles. And then on the y-axis, they put the percentile of the kid. Okay, and you can see two features here. One is that the whites are higher than the blacks at every level. So if you start at like down here at the 30th percentile and you're black, the kids are going to end up lower than whites who started at 30th percentile. Even though their parents had the same income, there's still a big gap. And that's something we're going to try and figure out how much of that is contributed by neighborhoods. Okay, that kind of makes sense. The other thing you'll notice is that these lines are pretty close to parallel. So it's not the case that the slopes are so different. So it's just that there's a big absolute gap between them. Okay, so now I'm going to start talking about what we bringing to the table in this paper. So I'm going to talk for the next couple of slides about the data that we use. And I apologize if you're not a data-oriented person, but I'm assuming that everybody who's doing advanced degree in statistics and economics or math and economics at CUNIF is really familiar with the problem of organizing data. So I'll talk about that. So what we do is we start with all families in the 2000 census. So there's 300 million people or 325 million people at that time in the United States. So there's about 175 million families at that time. We keep children who are 9 to 17. So those are going to be the people that we focus on. And so those kids were born in the 83 to 91 period, and they were living with at least one of their own parents. So we're going to toss out people who are not living with a parent. And we're going to keep only white and black families. for a variety of reasons. So we're going to toss out Asian and Hispanic families. Now, one advantage or disadvantage of that, depending on how you think about it, is we end up with almost nobody whose parents were born abroad, or nobody who was born outside the U.S. Okay, so most immigrant children in the U.S. Um, are either Hispanic or Asian these days. We're going to link the families and the children together, each of them to records on their earnings in later years. And so we're going to link these to this data set known as the LEHD, or Longitudinal Employer Household Database. And that's using data that comes from a tax system that's used in the United States to collect money for unemployment insurance. There's sort of three separate tax systems, but one collects data or taxes for unemployment insurance. A separate one collects data for taxes for pensions. Okay. But an advantage of this particular data set in the United States is you have to pay taxes on all of your earnings. No matter if you earn $2 million, you still have to pay a tax on that. So they collect all this information without any censoring, without like eliminating people in the top 5% or 1%. And it's going to give us also quarterly earnings. So we have a fair amount of detail on how people are moving from quarter to quarter. Okay, and here's going to be how the data works. So we take a 2004 census. Everyone's in this, well, virtually everybody in the country is in this sample. So we take a parent and a kid, and we take the other families in the census tract. And then we're going to measure their earnings in 5-year windows. And the parents, we're going to measure their earnings 2003 to 2007. That's going to be our main measure of the parents' earnings. So that's just a few years after the kids were 7 to 13. So when the kids are kind of teenagers. We're going to look at the kids when they're in 2018 to 2023. As I mentioned before, we're going to use the income earnings of the highest earning parent. Now, the reason for that is we've done all kinds of different experimentations with that. And we believe that that's a better representation of the kind of economic status of the family than the average earnings of the two parents. So think about it. If you have like one parent who earns $100,000 a year versus two parents who each earn 50, which of those two families is more advantaged? I would argue that you really want to focus on the $100,000 as the kind of measure of the status of the family. And that I think is a better measure. And that's what we're going to use. We have some disadvantages with this data set. It's kind of similar to the Social Security data set that Spanish economists used to study similar kinds of issues here, in that we don't see how much you work in terms of hours per day or days per week or days per month. Instead, we just see total quarterly earnings and how much you earn from each employer. So what we do is we take only quarters where you've got positive earnings. So we toss out periods where you're unemployed or on vacation or not working. And we are going to focus on earnings during quarters where you earn at least the equivalent of the minimum wage, which in the US is about $3,300 a month. Okay, that's kind of a full-time job in the US. So it's a little bit higher than the minimum wage in Spain. Well, the way the euro is going, it's not going to be long before. When the euro hits 1.7, it's going to be the same. Okay. And we're going to do a statistical technique to address the concern that maybe we're not getting a reliable measure of the parents' earnings, even though we're using a 5-year average between 2003 and 2007. Excuse me, 4-year average. We're going to use the instrumental variables technique and instrument the earnings with earnings in the 2010 to 2014 interval. And that addresses some concern in the literature. The original literature on intergenerational transmission was about intergenerational transmission of occupational status. Okay, and you may know that. And that's what sociologists have concentrated on for a very long time. And arguably, the earnings of the higher earning family member is kind of a measure of the occupational status of the family. So if you have a very well off family, in fact, probably only one person works. And so you wouldn't want, or maybe the spouse only works a little bit. That's pretty common among high status Americans. So we felt that was a better measure. Yeah. I'll show. I'm not going to show some results, but I could talk about the results. So here's what we've got as a picture. Here, over here is our family, and over there is the LEHD data set. And so we're going to measure the children's earnings over here in 2018 to 2023, which is on average around 20 years after the kids are observed living with your parents. We're going to observe the main parent earnings measure is going to be here, which is just a few years later. So the kids are going to be 12 to 20. Okay, so just finishing high school or just starting college kind of era. And so if you take a 13-year-old kid, sort of the middle of our age range, whose parents were 25 years old when they were born. Now, I realize that's extremely young by Spanish standards, but that's kind of average for our sample. Uh, then the parents are aged 43 to 47 in this first interval, P1, that interval right there, 50 to 54 in P2. So that's kind of the period when they're at their peak of their earnings in most studies. And the kid is 31 to 36. So kind of at the not just getting well, maybe just getting started in Spain, but getting kind of into the first set of main jobs they're going to have, the main career parts of their jobs. So, like if you're until relatively recently, even if you finished your PhD, even if you do a PhD, by that age you would actually have a real job. Okay. Okay. So as I mentioned, there's a bit of detail on this. So we start with about 30 million kids. Okay, this is always the sad part about economic research. We start with about 30 million kids who are 9 to 17. And then we have to get kids who they can actually link in the census to this administrative data, which means they're actually like legal residents, that they actually worked at least 4 quarters and things like that. So that gets us down to around 10 million. And then a few get excluded because the parents didn't work very much. And more get excluded because they didn't earn at least $3,800 per quarter on average. So we end up with only about 5 million. Okay, that's still a very large sample, but it's a somewhat restrictive set. Okay, so here's some summary statistics. So just to set the stage, over here is what you would get if you looked at all children in the census. Okay, and if you take such children who's living with their parent at age 9 to 17, around 19% are Black, 72% of their parents are married. So lots of people in the United States their parents aren't married. Lots of people are living with a single parent, actually. Their parents' education is about 14 years. 93% of the parents worked, at least one of the parents worked. If we go over one column, we look at the people who parents are working a fair amount. In other words, they earned at least $15,000 the year before the census, which is kind of equivalent to our $3,300 per quarter kind of standard. And you can see what that does. So if you look, what happens if we concentrate on the higher earning parents, that eliminates about 5 percentage points of Blacks. Okay, so Black families tend to have lower incomes. A little bit, we get a few more married parents, 80% instead of 72%. A little bit higher educated parents, all of them are working and the earnings are higher. Now over here is our main estimation samples. These are the parents that we're going to see. So about 10, about 10% of our children are Black. About 80% of our parents are married, which is very similar to this census sample. Their average education of their parents is around 14 years, so similar to our census sample. And you can see some differences between the Black and whites, which I'm going to talk about in a few more slides when we come to look at them more explicitly. Okay, so the first thing we're going to do is we're going to take those samples and now we're going to fit these models. And we start with a very simple model where we just run a regression of earnings of the kid. This is the average earnings of the kids in the early 30s on the average earnings of their parents when the kid was a teenager. Okay, think of it that way. And it's a log regression, so this is an elasticity, and the coefficient is around 0.3. You can see what difference does it make if we just use an OLS regression in column 1, or we instrument the earnings of the parents. That raises it a little bit, so 32% versus 28%, which is consistent with a little bit of attenuation bias. So people's earnings even a 4-year average of earnings is a best possible representation. So from the rest of the paper, we're going to use this IV. And then the other thing you'll notice is here we've got a complete set of dummy variables for all the commute zones in the US. There's 700 commute zones in the US. So a large one is basically most of Los Angeles, but many are quite small, like counties of Wyoming, where 12 people live. So if we do that, though, you can see it slightly lowers the intergenerational correlation coefficient, and that's because one of the things you inherit from your family is living in a higher or lower wage place. And if I take out that by including the CZ effect, it lowers the intergenerational correlation a tiny little bit, but not too much. And the R squared is about 10%. So this explains something, but not an enormous amount. There's still a huge amount of variability in children's earnings, even if you control for their parents. Okay, here's what the relationship looks like. And I'm showing you here two samples. Our main analysis sample is in orange, and that's imposing this restriction that the parents and the kids earn $3,300 per quarter on at least some of the quarters in their intervals. The basic sample where we can get almost everybody is here. And you can see these are pretty close to linear. This is not a percentile graph. This is a log earnings of parents and log earnings of kids. But it's still pretty close to linear. If we do black and white, the blacks are below, the whites are above, very similar to that graph I showed in the introduction or the early slides of the paper. But they're also both pretty close to parallel. And if we do the preferred technique that Chetty and his co-authors use, which is to use a rank, it's not too bad. It's pretty close to linear at the bottom, but it's got this curvature pattern at the top. Okay, so we prefer the log regression. It's also easier to interpret. So we're not gonna use this transformation. We're gonna use the log regression. Okay, now how much neighborhoods matter? So remember, what we're going to do is we're going to take the simple model and we're going to add one more variable. So simple models in column 1, we saw that before, 0.295. That's the intergenerational correlation coefficient. Column 2, we do something very, very straightforward. We say, okay, forget your parents. Let's just include the average earnings of all the parents, including your parents, in your neighborhood. And that raises the coefficient to 0.5. Okay? So there's something going on because that coefficient is enormously bigger than this coefficient, twice as, or almost, 35, 40% bigger. And R squared isn't that much worse. And so if you think about what happens then in column 3, we include both your parent and the neighborhood. And it's an exercise that we would put on a master's level exercise in econometrics, maybe in your exam later this year, will be to show that if you start with column 2, the sum of the coefficients in column 3 has to add up to what you see in column 2. So when you include the average for the neighborhood, you can split it out into how much of that is due to just your parent and how much of that is due to the other parents. And you can see, surprisingly, that the coefficient for the other parents is actually bigger, about the same size, but a little bit bigger than the coefficient on your own parents. So if anything, it's more valuable to have other parents being rich than your own parents. Okay, kind of surprising. And then finally, in column 4, we don't include anything about the parent earnings in the census tract. I should say, I didn't mention this. The way we're defining neighborhoods is what's called a census tract. A census tract is a pretty small level of geography. There's about 4,000 families in a tract. And we're measuring the earnings of the other parents who have kids of your age. So we're thinking about it as, that's a broad representation. That's a pretty good representation of the other parents. But there are some other people living in that census tract who don't have kids or don't have kids in that age range. They're not included here. This is just the other parents with kids in the same range. Okay, and when we include just a dummy variable for that, we get the same coefficient on the parent, your own parent, but and it raises the R squared a little bit. I haven't got the R squared there, but it doesn't raise the R squared very much. Okay. So here's our first exercise, which is, okay, you've shown me what happens if you include these two coefficients. In column 1, I've got your own parents, 0.23, the other parents, 0.25. Now what happens if I include lots of other stuff? So one thing I would include is the kid herself. We're pooling boys and girls here, by the way. So is the kid herself a male or a black?
or does she have a single parent? Do both parents have earnings? And this is a very surprising set of results, I think, probably from what, you can certainly what I was thinking. So if you look at the first, obviously, if you're a black kid, you have lower earnings, even controlling for your parent in your neighborhood. If you're a male, you have higher earnings, even controlling for the parent in the neighborhood. That's a pretty well-known kind of gender gap in earnings kind of phenomenon. But you see that if you're a single parent in 2000, the coefficient is only 0.016. So basically, the single parent per se doesn't matter very much, hardly at all. What really matters is average earnings of your parents. So it doesn't really matter if you have a mom and a dad, as long as somebody's got some money. That's kind of one way to put that. If both parents work, if anything, that's slightly negative. So that isn't really helping you. Um, and then I'm going to talk about column 3 later. And you can see that adding those variables, although particular black race and child male have pretty strong effects, it doesn't change the main coefficients that we're interested in very much.
To the extent that if they're in the same neighborhood, these are small neighborhoods, more likely they're going to be going to the same school.
Yeah.
So actually, you're taking into account in that sense their friends' parents' income.
Yeah, that's what we sort of had in mind.
Okay.
That these are your friends' parents' income. Now, we have done something which is pretty important, but I unfortunately haven't got the results disclosed. So imagine I had your neighborhood here, and there's a whole bunch of neighborhoods around the outside. So we can include the parents in your direct neighborhood, which is pretty small, usually just 4 or 5 kilometers across at most. We can include the kind of the donut set of neighborhoods around that. And that sort of gets at the school district, because on average, the school district is much larger than your little neighborhood. And what we find is that what matters is the neighborhood, not the donut. Now, they're highly correlated. So if you don't include your own neighborhood, the donut guys do pretty good. But if you include them both, it puts all the weight on the neighborhood, not very much weight on the donut. So our interpretation is there's something you're kind of acquiring from those close peers on average. It's still there's still a small coefficient there, like 0.02 or something, but it's not very large. So we think the main mechanism is probably coming that way. Yeah.
Doesn't it sound a little bit like Heckman selectioning this? That the small neighborhood, if it's richer people who goes to the very little neighborhood versus the other thing.
It could be, yeah, yeah. I mean, that the problem with all of this research, the spread on, is you aren't doing very much on the causality. Now, there is an attempt to do causality by Hendren and Chetty and Hendren, this very well-known set of results, which look at families. They have 2 kids, and one kid is mainly raised in one neighborhood, and another kid is mainly raised in another. And what they show in that analysis is the coefficient you get on the neighborhood is about the same size as the one you would get from a kind of they don't do a model like this, but you would kind of infer from a model like this. So their results suggest that the neighborhood effect is largely causal. Now, Mr. Heckman kind of has a lot of concerns about that particular model. So although he's arguing about it in the Wall Street Journal, so it's a little hard to have a technical discussion in the Wall Street Journal, but he believes that there's some problem with that.
So more than Heckman, I was thinking Fogli Guerrieri. They have these papers where, like Benabu and 90 something, and they have these papers on selection and people move into
I'm
neighborhoods.
going to talk a lot about neighborhood selection next. So yeah, let me maybe, but it is a good concern. It's something that, in fact, it might be the next slide. If I'd ever presented this paper before, I would know. Okay, wait a minute. I'm going to do black-white first. Okay. So just to start off with, here's the comparison between the first column is the mean of outcomes for white kids, and the next 2 columns are the gap between black and white kids. So black kids, and they're with and without CZ effects. Okay. Now remember, our models all have CZ effects. We're controlling for what city you grew up in. But black kids have lower earnings, about 25 to 28% lower. They have a lot lower mean parental earnings. Their parents, on average, earn 42 log points less, which, if you remember, 42 log points is like 60%. That's a pretty big gap. Their neighborhoods are also poorer, so their average earnings of their neighbors is about 30% lower, 30 log points lower. But their neighbors are also quite a bit more black. So their average fraction black for whites is only 5%. For blacks, it's about 55%. Okay, so black people tend to live in pretty black neighborhoods in the United States, even controlling for their income, actually. So you could ask, how much does it matter to know parent income and neighborhood income in explaining this pretty big gap? So we start in column 1. That's the gap in earnings between black and white kids in our cohort, 25 log points, pretty big. If we control just for their parents' earnings, remember the coefficient, this doesn't have neighborhood in it. So it's a 0.3, right? And that drops the coefficient down to 13%. So half of the black-white gap is attributed to having poor parents. And then in column 3, we include both the neighborhood earnings and your parents' earnings, and that drops it down to 0.09. So a very large chunk of the black-white gap, but not all of it, is explained by a combination of lower parent earnings and lower neighborhood earnings. And you can see that's true, and that coefficient is about the same. If instead of controlling for neighborhood earnings or anything like that, we just include a set of unrestricted dummy variables for what tract you grew up in. Okay, so knowing the neighborhood earnings is about the same as knowing the tract that you grew up in. And we can also include interactions of having parent earnings with black and average parent earnings with black. There is a bit of a negative effect here, this coefficient. So the effects of neighborhood earnings is a little bit smaller, actually, substantially smaller for black kids than white kids. And that's something we're exploring, but I haven't got too much to talk about today. Okay, now talking about neighborhoods. Neighborhoods, as we've sort of been talking about, neighborhoods could matter for a variety of reasons. So you students might not know this, but labor economists are different than other economists because they really focus on measurement more than anything else. Okay, and the most obvious for labor economists, the most obvious reason why neighborhoods matter is because you have a lousy measure of parents' earnings. So if you think about all the people that live in a neighborhood, right? So a neighborhood has got like all certain value of houses and characteristics and stuff. If you see a family that lives in this neighborhood that's particularly low income, there's probably something about them you're not missing. Like maybe the grandma is really rich, right? If you see, on the other hand, if you see like a really high income in a kind of a lower average income neighborhood, there's something kind of wrong with that family too, right? There's like, they got high income, but it's all like criminal or something. So I'm not necessarily, but okay. So that's one explanation. Another thing that's probably came to mind right away, which is other family characteristics that matter predict neighborhood. So, for example, if you've ever seen the movie Down and Out in Beverly Hills, it's about a family that really wants to live in Beverly Hills. That's a part of LA which has really good schools. So the guy is kind of poor, but he wants his kids to go to the Beverly Hills schools. So he kind of does everything he can to sneak in so his kids can get into these better schools. So parents that really care about good schools might live in really good neighborhoods. Okay, that's an unobserved characteristic. There's a couple of other questions which are relevant here. What other characteristics predict it? And then how does access to neighborhoods matter? Is there any evidence of discriminatory effects and so on? So here's one way to think about this. So here what we do, remember I showed these regression models where I had parents' income and a fixed effect for the tract. So that fixed effect for the tract is capturing everything about that tract that's relevant for the success of the kid, except their parents' earnings. So that's going to everything, that's an encompassing measure of the quality of the neighborhood. Okay? Take that fixed effect and put it on the left-hand side and now try to explain it with other stuff. Okay? So what we're trying to explain it with is mean parent earnings, fraction black in the neighborhood, fraction male, kids in the neighborhood, single parents in the neighborhood, the employment rate in the neighborhood, and so on. And you can see mean parental earnings has a pretty strong effect, okay, about 0.2. Fraction black has a negative effect if you don't control for parents' earnings, and male has an interesting effect. The more males in a neighborhood, more male kids in a neighborhood, the worse the kids do on average. Now, some people may already be thinking of good theories for this. That's possibly a whole paper or several papers that can be written about this. It turns out that's having more males is a little bit bad for the boys, and it's really bad for the girls. Okay, so if any of you have daughters, take a look around. If there's too many boys, move them away. It's time to change neighborhoods. Okay, now in column 3, what we do is now we control for the neighborhood earnings, and that knocks out the fraction black. In fact, makes the fraction black go slightly positive, which might be kind of surprising for most people. So controlling for parent income, the quality of the neighborhood is higher if there's more blacks, right? Pretty interesting, right? It's still true that there's a small negative effect of boys. Okay, so these, we've got to do something about the boys. And then some other characteristics like the single parent share and the employment rate in the doesn't seem to do much. We also tried something that we thought would be useful, which is the value of the houses, the price of the houses in the neighborhood. So there's a lot of sorting models where the price of houses is a sufficient statistic for the quality of the neighborhood. If the reason why people are sorting is entirely based on their desire to get a good place for their kids, okay? So if you have that model in mind, then the mean log home value would be a very good control variable. And it has a positive coefficient, but it's very noisy, or we're not sure exactly why, but it doesn't really do much. So that suggests that basically mean parental earnings in the neighborhood is a pretty good summary, but there are some other characteristics that matter a little bit. Okay, so who has access to good neighborhoods? Well, now what we do is we take some characteristics of the neighborhood. The first is the mean parent income in the neighborhood. The second is the fraction black in the neighborhood. And the third is that fixed effect for the model, which says what's the overall quality in terms of the kids that grow up there, how well do they do later in life, okay? And in each case, we run a regression of those 3 variables on mean parent earnings and are you black and are you single parent. You can see if you think of the mean earnings in the neighborhood, it's very highly correlated with the earnings of the individual family. So families that have higher earnings buy higher neighborhood earnings in some sense. That 0.2 means if you raise the earnings of a family by 10%, they're going to be on average living in neighborhoods where other families have 2% higher earnings, 10 over 2. So elasticity of about a fifth. The fraction black, you can see black kids are much more likely to have high black neighbors. And on average, there's a little bit of a negative effect of family earnings on that. And then finally, the track fixed effects, you can see mean parent earnings have a strong positive effect and fraction black have a negative effect controlling for that. Okay. In the interest of time, I'm going to skip this next section. But the next section is an attempt to look across different cities and see are there differences in the relative extent to which black kids get to live in good neighborhoods. And we look at a couple of features. One of the things that's probably most interesting is we look at a measure of housing discrimination that was constructed by an audit study. So these economists a few years ago sent people out to look at houses, to look at rental houses. And some of them were white and some of them were black. And they tried to see to what extent the black house lookers versus the white house lookers were shown the same sets of houses. And what they measure is the extent to which real estate agents steer the black clients to black neighborhoods, okay, which is the way that neighborhood segregation kind of is enforced in a U.S. context. Basically, if you try and buy a house and you're a black person, they're going to kind of push you to buy in a black neighborhood. And some cities that's stronger and some cities that's weaker. And we tried to see if that is going on, is that one of the reasons why black kids in some cities are living in slightly lower quality neighborhoods as measured by the average earnings of the other parents that live in the neighborhoods. And there's a little bit of evidence for that, but not very much. So I'm going to kind of skip over that. And the last thing I want to talk about then is this decomposition of earnings. And this is going to take a while, so I want to allow some time. And if you know anything about my research in the last 15 years, I haven't really been working on minimum wages or immigration. Okay, I've been working on this. So is this decomposition, and the decomposition says that the earnings of a person can be decomposed into kind of a part that is permanent for that person, the alpha I, and another part which depends on what job they have. Okay, and that's the delta. And the delta is associated with a particular firm that you work at in that year if you're that person. And that's what the JIT. JIT is an index function that says this dude in this year is working at firm J. Okay, so as you move from Stanford to Berkeley, okay, you're going to get a delta that's going to go down 20 log points. And if you move from Berkeley to Stanford, you're going to get a new delta that's going to be 20 log points higher. Okay, that's the idea. And in previous work, Jesse and Moises and I have looked at how these deltas differ across cities, and access to jobs is different across cities. And we found that if you just decompose earnings of people, that about 2/3 of the variance of earnings comes from the person effects, 12% from the deltas, and there's a pretty large component, 10%, from the fact that high-wage people, the people with high alphas, tend to get high-wage jobs, okay? And actually, everybody kind of knows that. So if you think about, like, I want to apply for a job at Google, well, sorry, you're not quite good enough to get the job at Google. You're going to be working at Joe's computer shop down the street, okay? So there's definitely an element of sorting going on. We also show that you can decompose the delta into a part that's due to the city that you live in, and a part that's due to the industry that you work in, and a third part that's due to whatever's left after that. Okay, and on average, that about 13% of the variance in job quality is across cities, 22% across industries, and 65% is kind of whatever's left over. Okay, so we're going to be talking about that a little bit. And why is CZ in particular our interest? Because many people, it's not quite as bad as the archetype of some European countries like Southern Italians or something, but a large number of Americans live very close to their mother. Okay, and I can tell you it's not because their mother does their ironing. I like to make that joke in Spain. It's because people basically like to live next to their mother, or there's a variety of reasons for you want to be close to your family for other reasons. So we're going to decompose this. All right, how do we do it? Okay, so here's our first cut at this. What we've done here, column 1 is what we've seen before, the 0.22 for your parents' earnings, and the 0.23, this is slightly different because it's a little bit different sample for the average earnings of the other families there. And now what we do is we decompose the kids' earnings later in their life into their person effect. So that's the part that they take wherever they go. And then the average firm effect that they get. Okay, so that's the premium that they're getting. And you can see that of the 0.22 for your parents, 19 log points of that, so the majority, is coming through the person effect, but there is an effect on the firm component. So having higher income parents gets you access to better paying jobs. Okay. Similarly, the tract effect works almost the same. So having higher income neighbors, that improves your person effect. So it's somehow maybe improving your human capital, for example, but it also improves the quality of the jobs that you can get. And so we're estimating that about 15% of the intergenerational correlation from both of those two things, the neighborhood and your parent, is coming about from the firm component, and 85% from the person effects. Now what we do in the next part is we decompose this firm effect into the CZ, the industry, and what's left. So that 0.034 mechanically adds up to these three terms. So 8 out of 34 is from the CZ, 9 out of 34 is from the industry, and 17 out of 34 is because you're getting a higher quality in firm in the same industry in the same CZ. So that's the difference between Stanford and Berkeley. Okay, you're in the higher education, you're in San Francisco Bay Area commuter zone, but you're working at a better paying firm. And then the 8 out of 34 is the CZ, and 9 out of 34, so roughly comparable. And you can see, interestingly, the shares are a little bit different. So CZ is a bigger part of your neighbor's earnings, and the remainder is a bigger part, and the industry is a little bit less. And one of the findings we have in this paper, although we haven't got this disclosed yet, this industry thing is very gendered. So you get, especially if you're boys, you get a lot from your parent if your parent is male. And if you're a girl, you get a lot from your parent if your parent is female. And that's one thing we miss if we take just one of your parents, is we kind of mess up that gender thing, because basically women tend to work in industries that are a little bit gendered, and men tend to work in industries that are a little gendered. And the parent of the same gender is a good indicator of what you're going to do later on in life. Okay. Oh, sorry. There is interesting phenomenon in the data. Uh, 3 or 4% of people work at the same firm as their father or their mother. Okay, and there you're going to get the same firm effect as them. Okay, now it isn't so big in our specification because we're observing the parents 20 years before, 18 years before the kid has a job. So a lot of those firms have disappeared or moved on or whatever. But you can look at people who work at the same firm as their parents, and you see that for them, the pattern is a little different, but the vast majority of the data is people who don't work at the same firm as their parents. So we're going to ignore that for now. Okay, now we're going to do what you asked me to do. So we're going to take, this is the first column, is the earnings of the kid. Remember, we've got the parent, and we break the parent into two parts, the parent person effect and the parent firm effect. And we break the trapped into two parts. 10 more, 15, 20. Well, I want to allow time for questions. Okay, so I'm trying to keep it up, and the people in the back are flagging, so I don't want it to get too tired. Okay. So remember, if you don't break it out, you get like roughly similar coefficients for the parent earnings and the neighborhood earnings, and now you can see you get roughly similar coefficients for the two components. So you get like 0.24 for parent person effect and 0.22 for tracked person effect. So it's not quite, it's a little bit bigger for your own parent, but it's almost as good to have high human capital neighbors, parents, as it is to have a high human capital parent, according to this specification. And similarly for the firm effects, it's quite useful to have a parent who is working at a good firm, but it's also quite useful to have, you okay? Yes. It's quite useful to have nearby parents working at good firms. And now we're going to decompose that into where it comes from on the kids' side. Okay, so, oh, sorry. Now we're just going to do the percentages. Sorry. So you can see 88% of the person effect is coming in. 88% of the mean earnings effect is due to person effect, and around 10% to the firm effect. Now what we do is we take column 1 is the coefficients, but now what we've done in column 2 and 3 is we've broken out the kid into a person effect and a firm effect, but we're not showing the coefficients, we're just showing the percentages. Okay? So you can think about it as that 0.249. Sorry, I got this wrong the first time. This 0.249 of the parent person effect on the kid's earnings, 88% of that is transmitted to the kid's person effect, 10% to the kid's firm effect. So very little of that is transmitted to the firm effect. Most of the effect of having a good parent person effect is the kid's person effect. And that's even more the case with the parent firm effect. So basically having father or mother who worked in a high wage industry during the time you were a teenager, that transmits into the kind of industry you're going to work in very strongly. So basically all of the effect of family on the firm that you're going to work for arises because the high wage firms the parents worked at transmit into high wage firms that kids work at. And similar pattern, but not quite as strong with neighborhoods. And so we think that what's going on here is, to simplify things a little bit, there's sort of two main components of earnings that this AKM type model identifies. Something like human capital, which represents the earnings that you could get anywhere, and something like job opportunities or job quality, some of which is driven by local opportunities like what city you live in or what industries are nearby. But some must be driven by something else, because our models have CZ fixed effects, and when we look at the industry component, is not huge. It's suggesting something like connections or network effects, things like that, where if you've got a parent who had a good job in a high-paying firm, or if you had neighbors, parents that had good jobs, that's going to influence the probability that you yourself gets that, even controlling for your average characteristic that you can take any job. Okay? All right. So then, to summarize, the existing literature suggests that both parents and neighborhoods matter. We're focusing on children, parents, and neighboring parents. So we sort of take this neighborhoods matter general conclusion and we give it a very specific context, measure the average earnings of the parents in the neighborhood. And we find that that matters a lot. Average parents' earnings in the neighborhood are close to a sufficient statistic for neighborhood quality. They're not fully all you need to know, but they're pretty close. And we're not entirely sure all of that effect is causal, but there is some suggestive evidence. For example, this neighborhood steering thing, or the Chetty and Hendren work that we are kind of building on. We also show that sorting matters a lot. So neighborhood quality is related to your parent earnings. It's related to race. One of the reasons why why Black kids have lower earnings later in life is that they grew up in slightly less privileged neighborhoods, and that's correlated with their race. Particularly if we're thinking about the Black-white issue, parental earnings explain 50% of the Black-white gap, and neighborhoods explain 15% more. So 2/3 of the Black-white gap can be explained by these two simple variables, which in labor economics, that's a major victory. We don't usually explain 2/3 of anything in my field. Conditional on neighborhood mean earnings, the larger share of Blacks in the neighborhood is actually slightly positive. It's not negative. So it doesn't look like Black neighborhood per se is the problem. It's that on average, Black families have low incomes, and low income neighbors are kind of a problem. So if you want to live in a high Black neighborhood, which a lot of Black families do, you're going to probably have to choose a neighborhood that has lower family earnings on average, and that is going to be somewhat bad for your kids. Okay? The Black-white gaps in neighborhood quality and child earnings are larger in more segregated and discriminatory cities. That's the part I skipped over. And our AKM decompositions say that the largest component of both neighborhood and parent transmission comes from the person effects. That's about 80 to 85%. Another 10 to 15% is coming from the firm effects, and the firm effect component of the parent and the neighborhood both mainly work through the firm effect of the kid, which suggests that there's something other than human capital that's probably at least playing part of the role here, something like a network access or connections or something like that, that we're going to hopefully work on in future work. So I'm going to stop there and open up time for questions.
So thanks for the very interesting talk. So every time we hear about neighborhoods matter, I think, okay, so what's the actionable point we can have? And there's all these studies about moving kids from poor families to nice neighborhoods, and that has a positive effect. But I always think, isn't this a zero-sum game? The people who move to the nice neighborhood do better. They probably make the neighborhood slightly worse on average, and those left behind are probably worse off because the best people in their neighborhood left. So where do we go from neighborhoods matter to?
Yeah. We're not really trying to say anything about a policy in the paper, really. Strictly speaking, the kind of model we've got here, it's linear. And so in a linear peer group model, you're absolutely right. It's a zero-sum game. So if you replace a low-income family, replace a higher income family neighbor with a lower, it's going to lower the earnings, and the average is going to cancel out. We have tried to investigate whether there's any nonlinearity in that peer effect. That's one route that some people have looked at in the past and said, well, maybe high income neighbors matter more for low income families. We don't find that. So I didn't show the results, but we don't find much of an interaction effect. Yeah, I think that's a big concern about this from a policy point of view, but we're not really thinking about, I mean, I'm not really a policy economist, despite what people think. So we're more thinking about it as how do we account for these large differences in, especially, for example, black-white? I guess you could say that if we had found really large differences across cities in the neighborhoods that black people live in relative to whites, and in some cities black people were, moving into very high income neighbors, kind of consistent with their own income, and then in others they weren't, then there's some kind of evidence of something in those cities. But we don't find large differences there. We find that this discriminatory pattern does matter a little bit, but that's maybe the closest thing we have to a policy result. Yeah, I haven't really thought much about that. I think the other thing that people have found historically in the United States was, if you try and actively move low-income people into a neighborhood, people move, right? So if you disrupt the equilibrium, it isn't going to stay put. Yeah, and so I've always been skeptical of those kind of policy experiments myself for that reason.
How would you explain the opposite effect? I mean, when there's gentrification in one neighborhood, and then the people that are worse off, they just move away. They don't get to do better. Is it a time effect or?
Rent.
Mhm.
Usually the mechanism driving the gentrification is um, a neighborhood becomes more valuable, and the landlords and raise prices, and sometimes they actually explicitly kick out the residents because they renovate the building, and that gives them a way to disrupt the leases and stuff. And so they take a low value neighborhood, low land price neighborhood, and create a high land price neighborhood in that location. And then with the high land prices, low income families are driven out by the market mechanism. So I think that's what's really going on in the gentrification case. Yeah. Yeah. So we're not, as I said, we're not really talking about like ways that you could intervene here. We're just sort of giving a picture of this component of mobility that is highly correlated with neighborhoods, and saying, well, that's a thing that you need to recognize if you're trying to think about how neighborhoods or how families choose where to live and how that matters for their kids. Yeah.
Is the neighborhood effect the same? So that donut that you were describing.
Yeah. So we haven't done quite as much there as we maybe could, but the main thing we've done, if we take the 100 largest CZs, they're almost all completely urban.
Really?
Okay. And our results are basically the same as that. Now that makes sense, because the 100 largest CZs is like, of our 5 million, that's like 4 million or something. So the preponderance of our sample is urban. We haven't explicitly tried to look at these more small rural places. In the U.S., I don't know. Do you think that Wheeling, West Virginia, is urban or rural? Yeah. So the pockets of poverty that people are talking about in Appalachia and places like that, they aren't exactly rural. Like, they're not farm country. That's Iowa. So Appalachia is small towns and some, 100,000, 200,000 person cities. So a lot of the poverty and really hardcore, opioid epidemic problems and so on are in these areas that are sort of semi-rural, but not exactly, idyllic rural farms or anything. It's some kind of a mixed thing. Maybe we certainly have a setup. We could look at it, but we haven't done that.
How about the neighborhoods where the kids live? Are they affected by their neighborhoods where their parents lived at the time? Or there's a selection of them moving to higher paying neighborhoods, and therefore that actually affects your results? Because if they're in the same neighborhood,
Yeah.
but
Um, So, when we do that CZ component of the job quality variable, that's kind of isolating that because the CZ component of your parents' earnings captures the average earnings pay difference that associated with the city where they lived, which is where you grew up. And then the CZ component of your earnings captures the pay premium for where you worked in your 30s. Okay, now those are fairly highly correlated, but not, the correlations are we saw some of them in passing there. I think if you ran it just as a correlation rather than a regression coefficient, it's around 0.3. So you do tend to get a fair amount of the same place. And that's largely because lots of apparently the university students are getting younger. It's largely because there's a lot of people that live in the same CZ as their parents. Yeah, but not everybody. Yeah.
Very curious about. Did you run a regression on the persistency of the personal effect? I was not sure if I understood it in the table. So I will be interested in knowing if you take AKM very seriously and we believe in the how, how persistent is that across the personal effect across generations. Did you manage? Oh, I have never seen it run, and I think it will be.
You mean I run the person effect of the kid on the person effect of the father, or the person effect
perhaps
of the kid at different time periods?
The personal effect of the kid on the personal effect of the father, and perhaps other things.
Yeah, we did that.
Is that
It's 0.2 something.
that's what was there?
It's about the same size as your earnings on your parents' earnings.
And is it unconditional for things? How much it is?
It's conditional on the firm effect of your father or mother, and all of our models have CZ dummy and are you male and are you black. Okay, that's all. Yeah. So it's pretty big. It's about the same size as the parent thing on the total. But that's, you sort of knew that had to be true because, as I said, 85% of the total earnings effect is through the parent effects. Yeah. Yeah, go ahead.
Yeah, you said that the percentage of boys versus girls in the neighborhood could have a positive or negative effect. How is it that a bigger amount of male kids has a negative effect? And at what point does having girls change that, like turn it around?
So we haven't really done that much investigation of that. I think that's probably a good topic for future investigation. You would have thought the range of variation in the gender mix in neighborhoods is pretty small. So you never see neighborhoods where it's more than like 40%, more than 60% girls or more than 60% boys. So you're talking about a range between, pretty small. We're not sure. I don't really know. It just kind of pops out in the data when you look at it that there's a negative effect of having more boys in the neighborhood. And that effect is a little bit bigger on girls than it is on boys. So probably what needs to be done is people need to, somebody, us or somebody else needs to take these models and fit them. We have fit all the models just by gender. It creates enormous numbers of tables. And it's very hard to keep it organized. So we decided for this to just keep it at, one simple thing. But arguably what you want to do is you want to have a separate model for how families affect girls and how they affect boys, and then look at if there's some particular features of a neighborhood that are particularly good or bad for girls versus boys.
And in that same difference of numbers between boys and girls, if that is the reverse in a neighborhood where there's more girls than boys, does that not have any particular effect?
So it looks like if you have, if you go all the way from a 60% girl neighborhood to a 60% boy neighborhood, that would be very extreme, right? But if you do that, that's going to be somewhat bad for both the boys and the girls in that neighborhood. Now, it's possible that that is endogenous mobility. I don't know. There's a very well-known, well, not so well-known, but a very clever paper by an economist named Christian Dussmann. And he looked at Turkish immigrants in Germany, and he showed that Turkish immigrants in Germany are much more likely to move back to Turkey if they have a daughter than if they have a son, because they want their daughter to grow up in Turkey and not be around all those gringos. Well, I don't know what Germans call gringos, but that's what Americans call. I'm a gringo. Yeah. So they want to, there's more protection. Families are more trying to protect. Same thing with Catholic schools. Like families in the United States are much more likely to send their daughter to a Catholic school than their son. So there's definitely some protective aspect of families with girls, and I wouldn't be surprised if it's reflecting some of that. So there's something else that's wrong with the neighborhood, and it's showing up in that there's not as many girls there. That would be my hypothesis, but I don't have evidence on it.
Hi again, David. So let me ask to go back to something that you mentioned about the network effect. So can you tell us a little bit about any work that you are doing and so on the driver of these network effects? Is it, say, the schools? Is it, say, I don't know, the country clubs in the rich areas? It's just because so in the finance literature, nowadays, a big question that people look at is exactly what types of network matters, right? Is it the work that you do? Is it because, say, of your educational background, people going to Ivy League, or whether you play varsity sports, this type of things? So I guess with this, I mean, depending on the data, would you be able to say, I mean, is this coming from the school PTAs that people help each other, or the clubs, or religion, and this type of things?
I know. So there's a fairly extensive literature in labor economics looking at what happens to people who lose a job. Okay, and what you find is that when you lose a job, a lot of the speed at which you're re-employed is heavily influenced by whether you had a lot of previous coworkers who are in relatively good jobs nearby. So previous coworkers do provide some kind of a network for information or possibly references. So, the whole referral network idea. It's not entirely clear that that's what we've got, but I wouldn't be surprised if that's one part of it. Another part of it might just be that certain neighborhoods have good firms. So if you grow up in an area like Seattle, Seattle has, Microsoft, Amazon, Boeing. Those are relatively high-wage firms. If you grow up in like a lot of other cities, there just isn't such firms. But I think that the research on that is just kind of getting started as to what the right network measure is. Yeah, I think that's something that people could be studying in the future. Yeah. Okay.